Welcome students to the another chapter of class 10. Today I will be teaching you sources of energy chapter 14. Let us study about the characteristics of a good fuel. A good fuel should give high calories of energy. That is when things are burning, then it should give large amount of heat. It should not produce smoke. It should be easily available, easily storable, and easily transportable. It should be economical so that every person can use it. It should not leave any residue in the form of ash, and it should have not moisture. The best examples are that of a coal. Coals have got many varieties, and anthracite is considered to be the best quality of the coal. Other examples of good fuels are the LPG and CNG. Sources of energy. There are mainly two types of energy sources. One is conventional source of energy and one is a non-conventional source of energy. Conventional source of energies are those types of energies which are non-renewable and which we have been using it since long years. They are considered to be the wood, the flowing water, the fossil fuels which include the coal, petroleum and natural gas, the wind energy, and the biomass energy. The non-conventional sources of energy are mainly those types of energies which are considered to be renewable. For example, the solar energy, the ocean energy, the geothermal energy, and the nuclear energy. Today, we'll be learning in depth about the conventional sources of energy and non-conventional sources of energy. Under the titles of conventional sources of energy, we will be studying the fossil fuel, thermal power plant, hydropower plant, biomass, and wind energy. Let us start with the fossil fuels. What are fossil fuels? Fossil fuels are formed inside the earth. They are the remains of the plants and animals and have been under pressure and they have undergone temperature and pressure changes. And since after millions of years, they have changed into the fuels. These fuels are coal, petroleum, and natural gas. Fossil fuels are non-renewable sources of energy, so they should be used judiciously and can be conserved for our future generation. There are many disadvantages of these fossil fuels. They do air pollution, we get acid rain because of it, and they do the greenhouse effect. Whenever we burn the fossil fuels, large amount of gases are released which are harmful and cause air pollution. These fossil fuels contains large amount of sulfur and nitrogen in them, and when combustion, that is burning of this sulfur and nitrogen takes place, they convert into sulfur dioxide and nitrogen dioxide. Then this rises up in the air, they mixes up with the water vapor, and down comes the rain in the form of acid rain, either nitric acid rain or sulfuric acid rain, which causes large scale damages to our buildings, metals, and life. Greenhouse effect. Whenever the fossil fuels are burnt, large amount of carbon dioxide gas is released. This gas is heavier and they always stay closer to the earth. They help in increasing the temperature of the earth because carbon dioxide has got tendency to absorb heat and thus cause global warming. The second is about the thermal power plant. In thermal power plant, the heat energy is produced by burning the fossil fuel, either the coal, petroleum, and natural gas, and they are used to heat the water. This water then changes into steam, which helps to rotate the turbines. And because these turbines rotate, they help the generator to produce the electricity. The heat energy is converted into electrical energy. Most of the thermal power plants are located near the coal or oil fields. Hydropower plants. They are water power plants. Dams are built on it, and these dams first gather large amount of water behind them, and they allow this water to fall down on the turbines. And when they fall on the turbines, their turbines move and they are connected with the generators and electricity is produced. The many advantages of this hydropower plant. Water is a renewable source of energy. After the turbine flows, the water can be moved ahead. They do not cause any pollution, and the flood water can be controlled and it can be used for the irrigation because large amount big lakes are formed and the water from the rivers can be diverted. Along with the advantages comes the disadvantages. The building cost of these dams are very high. Now, since I told, large lakes are formed near the dam, and these dams, these lakes were initially the forested area or the people living there nearby. So these peoples have to be displaced, or the forest trees have to be cut. And when if they are not cut, all these trees are submerged down. And when they submerge down, they decompose and produces large amount of methane gas, which is again a greenhouse gas. So there are many disadvantages when the hydropower plant is formed. So here there is a thermal power plant. You can see over here, this is a boiler. This is a fossil fuel which is added inside the boiler and it is heated. These are the tubes. Water flows into tubes and it heats the water and again steam is formed. This steam has got large amount of kinetic energy. It will help the turbine to flow and these turbines are connected with the generators which help to produce electricity. Second is the hydroelectric power generation. Now, in the hydroelectric power generation, this is a dam and water is allowed to fall in the turbine. The water may move ahead downstream. Because the turbine is moving, this turbine are connected with a generator and large amount of electricity is produced, which can be transmitted by the cables with the help of transformers. We are going to study about biomass energy. And in biomass energy, we are going to study the technology which have made the biomass more better fuel. So let us study first the definition of biomass. Biomass, bio means living. So they are living mass. They are the waste materials and dead parts of living things. So biomass is made from the living things which are dead and they are the waste materials. For example, the biomass consists of all the mixtures or individual part of the wood, animal dung, vegetable waste, agriculture waste, sea waste, they all are biomass. Now, in biomass, since wood is a biomass, the wood have been improvised with the help of technology to form a charcoal. And from the animal dung, you can see people using the animal dung as a fuel for cooking, and you can see large amount of smoke coming out, and it is injurious for the person to cook under such circumstances. So this animal dung and all the waste can be converted into biogas. So with the help of technology, we have changed the wood to charcoal and the animal dung to biogas. And the charcoal does not give us out smoke much, and the biogas also do not give out smoke. So, and both of them are giving more energy than the wood. You might have seen during Holi the wood burning, they are yet orange or red light. But in charcoal, it is red, but it also gives blue flame. And that means the energy level is quite high. Now, they are smokeless also. Some of the charcoals, they give blue light, but charcoal, if it is of a very high standard, it will give blue, otherwise it gives red, but red also without any smoke. So, and energy level is far more than what the wood gives. So let us study in depth about the biogas. Biomass is decomposed by anaerobic microorganisms to produce biogas. So all the waste that is a cow dung is decomposed by the help of certain microorganisms and in absence of air. That is more important. And biogas is produced. It is also called as gobar gas, and this gas contains mixtures of methane, carbon dioxide, hydrogen, and hydrogen sulfide. How is this biogas prepared? It is prepared in a biogas plant. In a biogas plant, there's a big tank which is made under the ground. This lower part, which is under the ground, is called as digester. It has got a dome on the upper part where the gas is collected. This tank has got two sides. From one side of the tank, the dung is made to enter inside the tank, and from the other side, after the decomposition takes place, the fertilizer is formed and it is being taken out. And above the tank part is the part where the gas is collected, and a pipe, from a pipe the gas can be taken out. So the fertilizers that remains of this, that is considered to be waste, is not a waste. It is used as a fertilizer, and it is rich in nitrogen and phosphorus and is used as manure for the crops. So this is how I said this is a tank that is underground. This tank has got a dome up. Now it is on the two sides there are openings. From here the slurry of cattle dung and water, everything is allowed to enter it. Now it is decomposed in absence of air, so air is not allowed to enter inside. You can see no air is allowed to enter inside, so that after 3 to 4 weeks it will start producing gas, and once it starts producing gas, this process is continuous and the gas will come out as a continuous process. Now whatever is remaining down can be taken out as a slurry, and this is a fertilizer which can be easily taken out. There's a slab you can take out from here also, and here the gas is collected and it can be taken out. And there are villages in Gujarat also where all these pipes goes house to house, and it is giving gas which is smokeless. And people over there initially used to use gobar. Now they collectively collect the gobar at one place, and the whole village, it's a biogas which will give more energy and more smokeless, and the residue also is less. Second is the charcoal. When a wood is burned in limited supply of oxygen, again charcoal is made in absence of air or very little supply of oxygen. The water and the volatile materials of the wood is removed, and charcoal is left behind as a residue. The characteristics of this charcoal is it burns without flames, it is comparatively smokeless, and it gives high heat energy. See how this charcoal is being prepared. This man is pushing these logs inside a place where it is burning in absence of air, a very little amount of air. And you can see how they will convert. They'll convert it to this logs. You can see it is still a wood. And when we are burning, see, it is smokeless and gives large amount of heat. And next is a wind energy. Wind energy is used in windmills, and it converts the kinetic energy of the wind into the mechanical, and this mechanical energy can further be converted into an electrical energy. The kinetic energy of the wind can be used to do even the mechanical work like lifting water from the wells or grinding grains in the flour mills, which you can see since ancient times. There are many pics that shows that there's a windmill and they are lifting water from the wells, or there are grinding grain flour mills. So it has been going on since long to convert the wind energy into mechanical energy. Now, since this mechanical energy, turbines are connected with the generators, it can easily produce electricity also. So this wind energy can be either be used to do mechanical or to produce electric energy. A single windmill produces a very small amount of electricity. So a large number of windmills in a large area are coupled together to produce more electricity in the wind energy farms. The advantages of wind energy: it is a renewable source of energy. It causes no pollution, and the cost of the installation becomes less. There are certain disadvantages. The wind is not available all the time. The wind farms can be made only at a region near the ocean or near the sea where there is high speed wind, or in a desert region, or in a very high altitude place where there is large amount of uh, wind that is flowing, and the minimum speed that is required is 50 kilometer per hour. It requires a large area of land. So this is a windmill, and these are many windmills together, and therefore it is called as wind farm. Let us study about the alternative or the non-conventional source of energies, which are mostly also called as renewable sources of energy. The examples are solar energy, energy from the sea, geothermal energy, and the nuclear energy. Let us study about the solar energy first. Solar energy is the energy that is obtained from the sun in the form of heat and light. This solar energy is used in many devices, like the solar cooker where we can cook food, solar water heater where it uses water for warm water for heating, solar furnaces. We also use this solar energy and can convert it into light energy with the help of a solar cells. The solar cooker. So in the solar cooker, we've got some boxes that are painted black. Black means they absorb energy and they are insulated. Inside that box, we can put our food that is required to be baked. It is covered with a glass plate so that the heat, if it enters inside the box, is not allowed to escape out. Then there's a mirror which will maximum try to reflect all the light on the glass plate, so that the heat can be enter inside the box. The food is to be cooked is kept in the container that it can produce a temperature of 100 degrees to 140 degrees Celsius. Second is a solar water heater. A solar water heater has an insulated box painted black inside with a system of copper tubes. It is covered with a glass plate which allows heat to enter inside but does not allow the heat to escape out. When water flows through the copper tube, it absorbs heat and becomes hot. You can see over here. This is a black box inside which the food has to be kept. It is covered with the glass. When this is closed, the light can enter, solar light can enter inside. It is converted into heat, this heat energy, but this heat is not allowed to escape out. And this is a mirror. Light can fall on this and it is allowed to reflect on it. So maximum amount of light can fall on this surface so that the temperature can rise easily to 100 degrees Celsius to 140 degrees Celsius. This is a solar water heater, and you can see it works with the same principle that the tubes copper tubes are inside the glass panel, and once the light passes through the glass, the heat that is because of the light will not be allowed to escape, and these are all tubes, water tubes, and the temperature will rise, and as a result of this, the water inside this tank can become warm. There is a side from one side in which the cold water comes, and from one side the hot water. Then it is allowed to enter to the tank, and from the tank the water is allowed to go into the respective parts of the houses through the pipes. Then a solar cell. Solar cell is a device which converts the solar energy into electrical energy. It is made up of many semiconductors like the silicon, germanium, and gallium. A single solar cell can produce a voltage of 0.5 to 1 volt and produces 0.7 watt of electricity. So several solar cells are arranged in solar panel to produce more electricity. Advantages: it is a renewable source of energy, it produces electricity without any pollution, and it can be used in remote areas also where there is no power supply. The disadvantage is it uses only special grade of silicon and that is expensive. It uses silver for joining as a wire, as a conducting wire, and silver is expensive. The current produced is a direct current, and to convert it into AC current requires lot of cost. This is a solar cell. We don't want to go into the depth of N-type conductors, P-type semiconductors, but they are the type of semiconductors either in the silicon or the boron or the types of semiconductors, and this is how the cell looks, and so to produce electricity. This is a solar panel. Solar panels contains many solar cells. This is a solar lamp. Because of this solar panel, electricity is generated and you can easily light a lamp. Energy from the sea. The energy from the sea is obtained from in the form of three different types. They are the tidal energy, the sea wave energy, and ocean thermal energy. Let us study about the tidal energy. The periodic rise and fall of sea level due to the gravitational attraction of the moon causes tides. A dam is constructed at a very narrow opening between the land and sea. The movement of water during the high tide and the low tide can be used to rotate the turbines of generators to produce electricity. Sea wave energy. Waves are formed because of wind. So when a strong wind blows over the sea, huge waves are formed. The waves have large amount of kinetic energy. This kinetic energy can be used to rotate the turbines and to produce the electricity. Third is the ocean thermal energy. The top surface and the lower surface part of the ocean has got a temperature difference. The top surface is warmer, and as you move down, it becomes colder. Due to this, there's a difference in temperature, and if this temperature difference is at the depth of nearly 2 kilometers, is nearly how much? 20 degrees Celsius, then easily you can convert the energy into electrical energy by using a turbine. Social thermal energy is now a new way of obtaining energy, and it is being used at large places along the European coastal places. So here there is a tidal energy. How tidal energy is used to get convert it into electrical energy. So here you can see the water. Because of the tide, it will make the turbine move, and it is coming towards the land. So this is a high tide, when the water is going towards the land and it is covering a large area of the land. Now there is a low tide. When the low tide, the water is receding back. So again, because of this, the turbine is going to move. So either the water goes on this side or the water goes from this side, the turbine is going to move. And this will help when the turbine is moving, it is connected with the generator, and easily we can get electricity. Second one is the sea wave energy. There are different types of sea wave energy, how it can be produced. Different models are there. In this model, you can easily see that the water is entering inside a tunnel, and inside this, there is a turbine. Now waves have reached over here, but there's large amount of air inside it, and this air is being pushed up, and so because of that, the turbine moves. Again, when the wave is receding, it creates a vacuum by pulling the air with it, because it is moving back with energy, and it is pulling back, and this also creates the turbine to move. The last one is the ocean thermal energy. And as I told you, that the up surface is warmer, the lower part is a cold. At a depth of nearly 2 kilometers, the temperature difference should be nearly 20 degrees Celsius. Under such circumstances, we can use ammonia. Ammonia has got a very low temperature, that is the boiling point. The boiling point is nearly 32 Kelvin, and there are two pipes. In one pipe, there is a liquid ammonia which is on the warmer surface. This will be converted into steam, and this steam will make the turbine move. Now, when it makes the turbine move, that stream again can come down from the another pipe, and the pipe will make it go to the down place where the water is cold, and that steam will be again converted into liquid. Again, this ammonia is recycled back and is carried upward direction, and as it moves on the upward side, what will happen? The warmer surface will again convert it into vapor state, and this vapors will make the turbine move. And this is how the ocean thermal energy can be. From the ocean, the thermal energy can be used to make electrical energy. Geothermal energy. Geo means the earth. From deep inside the earth, the energy that is obtained is called as geothermal energy. As we go deeper into the earth crust, the temperature increases. Below the crust, there is liquid layer, that is a magma layer. The whole of the rock part is in a melted stage. And this magma part, when it gets collected some spots and started rising up, those spots are called as hot spots. So the magma moves up and collects below at some places, and they are called as hot spots. At such hot spots, if the underground water comes in contact with it, they get converted into steam. The steam has got more kinetic energy and high pressure. If we drill a hole to that place, the steam can rise up, and if we keep a turbine at that place, it will rotate, and if it is attached to a generator, it will help to produce electricity. So this is the molten magma part. Now this magma part can come up at certain place, and if the water is in contact with such layer, what will happen? Here, this is a water part. If it is in contact with such, it will convert it to steam. If a hole is made, then what will happen? The steam can rise up, make a turbine rotate, and that is how electricity can be produced. Nuclear energy. Nuclear energy is the energy that is released during nuclear reaction. During nuclear reaction, some of the mass is converted in energy. This is very important. Mass is converted into energy. It follows the equation E is equal to M delta mc square. Delta M means change in mass, certain mass, only some amount of mass is there. E means energy, which is equal to mass, and C means velocity of light. So during nuclear reaction, some mass is converted to energy, and this some mass will give large amount of energy. It's very large. These are nuclear fission reaction and nuclear fusion reaction. Most of our nuclear reactors follow the nuclear fission rule. Nuclear fusion takes place on the sun and stars, where continuously the hydrogen atoms, they fuse together to form a helium, during which large amount of heat is produced. You can see the sun burning because of large amount of this chain reaction that is going on over there. And we are still not able to control the amount of heat that is produced by the fusion reaction. And it is so destructive that our reactors are fission that can be controlled by us, but not the nuclear fusion. Yet we have not advanced to form any nuclear reactor based on the fusion. All our nuclear reactors are nuclear fission. follow the nuclear fission reaction only. So in fission reaction, a very heavy atom, that is a bigger atom, like a uranium or a plutonium, it splits into smaller nuclei. And when it splits into smaller nuclei, some amount part of the mass is converted into energy. It is used to make atom bombs and also to produce electricity. In a nuclear power plant, the heat energy produced by a controlled nuclear fission chain reaction, it is used to produce steam. And these steams helps to rotate the turbines to produce electricity. Nuclear fission reaction in which two smaller nuclei, they are fused together. Fission, bigger heavy atom splits up into two smaller one. But fusion means mixing of two small nuclei to form a heavier nucleus, and this releases a very large amount of energy. The energy of the sun is produced by the fusion of hydrogen nuclei to form helium nucleus. It is also used to produce hydrogen bomb. Advantages of nuclear energy. It produces a very large amount of energy per unit mass than any other source of energy. If safety measures are taken, it is more environmental friendly than any other fossil fuel. Disadvantages. The cost of the nuclear reactor is very high. The availability of this nuclear fuel is very limited. Nuclear reactors produce harmful nuclear wastes, which is very difficult to dispose. Such radiations can cause mutations in the living organisms. How the nuclear fission reaction takes place. Nuclear fission takes place when a very heavy atomic nucleus, such as a uranium, breaks down into two or more smaller pieces, and this will release large amount of energy. During this process, some of the mass, or that is of the original atom, is converted into energy according to E is equal to delta mc square. This is a neutron. It will come and bombard the nucleus of a heavy atom, and this neutron will break this heavy atom into smaller atoms, during which two small atoms are formed over here and large amount of energy is produced. Along with large amount of energy means there's a loss in mass. If I do the total of this plus this, and it should be equal to this, but no, it is a little bit less, little minute less, but that minute less, that is delta m, will release large amount of energy. So this is how the chain reaction takes place. The uranium is broken two, then further this reactions further goes on, and that is why it is called as nuclear fission chain reaction. Nuclear fusion. These are two deuterium atoms. It is an isotope of hydrogen, and they both fuse together to form a helium. During this, large amount of energy is produced. So again, you can see deuterium and tritium, they both join together to form helium, plus release of a neutron and large amount of energy. Okay, so two smaller atoms fuse together to form a bigger atom. Thank you so much.